Building an inductor is really easy. No, it's not. I'm talking about buck converters. Okay, so what you need is a couple of pieces to do it. It's really, really simple and easy to do. Anyone can do it. I'm using a variable resistor because what I want to do is have a power supply which I can change the voltage to match what I want. Of course, you don't have to use this. You can set the voltage, which makes it kind of inflexible. And I think if you're building one, you want one that you can change. Also, we're using these, which is the LM2675S adjustable. This is a 3 amp, guaranteed 3 amp circuit. You'll need an inductor which is capable of producing the current. There we go, this is what I'm using, which is a 221. 68 microhenries. Now I literally just grabbed up some pieces, so you need 2 capacitors. You can use one of these if you don't want to use a big potentiometer. A couple of resistors, 1K. And that's about it. So here's what I built. Here's what I made earlier. I've chucked it in a box. I put a fan in there because it's 3 amp. It does get quite warm. Let's see if you can see that. So as you can see, very simple circuit there. I've got 2 outputs. I had one so I can change and put whatever I want on it. And the other one is a USB. So here's my input. Obviously there, it's got one of these connections on it because it makes it easier for me to connect everything up. And I also have one of these. Now this is one of those eBay power supply voltage and current meters, and these are probably the worst things to have to connect up because the wiring on it goes slightly backwards. So what you need to do is basically you get all your parts together, and I'll put a proper one on screen. I was just trying to draw it out, and as you can see what I've done is the voltage in goes in, it's capacitor. Before it goes in, it comes out, goes into the inductor. There is a one-way diode. Oh, that's one of the things that I've missed off here on this pile. A capacitor, and then we have our resistors for our feedback, so we can alter the voltage. And then obviously you just have an output. It is literally that simple. You really don't need a lot of parts. 1, 2, 3, 4, 5, and the diode is 6 parts to make one, and 7 when you want one of these. It's really simple. I'll probably do a detailed video build because I'm making a parallel one, which means there's going to be 2 voltage supplies coming out from it. It takes you half an hour. Now it depends on where you get your parts. Obviously these I ordered from China and waited 3.5 months for them to turn up. I think it might have actually been about 4 to 5 months for these to turn up. Obviously they're quite hard to get hold of at the moment. These came from Maplin's. I got a big load of them. This is a, I think it's a 47. These I've had for quite a while. I have various different types of them. Any of them can be used while you're doing your build. And I particularly took this one. I do know that they do a 5 amp one as well, and I did put a fan in there. It does get hot, so you do need to put a heatsink on it when you're building. Now this is just a temporary housing on a perf board. The inductor is a 270, and it does really well at charging phones and batteries. Now if you're charging a battery, one of these are really essential, because when you charge your battery you'll have your battery voltage here which you can monitor, but you also have your current. And if you've charged batteries and you've looked at it, as they get more and more charged the current drops down on this, and what will happen is you'll get that current drop and you'll be able to see that your battery is fully charged rather than trying to overcharge it. So that's pretty much it. I haven't got current control on here. Some of you actually may need to have current control built into the circuits because you will get problems with lower current items heating up if they can't cope with the high current. I've used it to charge my power bank, one I built earlier. So you know, you've really got to think about what power you're going to need and what you're going to use it for. I'm assuming that people are going to use it just as general chargers or power outputs for various items and hardware that you have, and that's great. They do work really well. It gets quite warm, it's hot to the touch. This one's getting put in a bigger case to help with airflow, and this is just a templated design that I whipped up down in the workshop for seeing how small it could be made. Obviously I'm using 1 centimetre thick. This is actually old laminate flooring, because I recently did our laminate flooring, so it was lying around, so I thought, well, might as well use that. The potentiometers on the front, I've not printed any buttons out for it. This is just banged together in this fashion, just as a sample, but it does actually work and functions properly as it should. I use a broken linear power supply for it, which is supposed to be a set voltage but is uncontrollable. It's 1 amp, and I get 3 amps out, so I'm winning every time. So look on the screen, you'll see basically the topology of how a buck converter works, and simply just make sure that your diode is the correct one. Schottky diode. I didn't do the picture correctly. I'm terrible at doing these pictures. It's been a long time since I was at college when I had to do them correctly. So the diode, obviously, right, so let's go through the circuit quickly and you'll kind of get a gist for this. I need to move in a little bit closer. So inside the LM2675 or 76 or whatever it was, is a feedback here. This reads the voltage, which keeps on its reference voltage, which is why we need to pick these out correctly. We have an enable pin which just goes to ground. I did try switching, but it still stays on, but I had a really bad cheap switch. So the diode, when it switches on, the current goes across the inductor and is stored in the capacitor on the way out. So then the diode completes the circuit when this is off, so that you don't get voltage spikes. Obviously your capacitor, because I drew this completely backwards, your capacitor then stores your power when you're putting it out. Now don't go for a too big a capacitor on the exit, because otherwise the IC won't be able to cope with the voltage changes, drops, etc. that occurs when you're drawing a lot of power. I've used a 470 and I have 1000 on the input, because I'm using quite a low current. It's supposed to be something like 12 volts 1 amp, and it's putting out somewhere closer to about 19.6. so there is a bit more current coming through, a lot more voltage, and of course it's no good. And the reason why they're faulty is because of the electric company boosting the voltage. So these old linear power supplies are more likely to break your electrics rather than work with them. So this is like a little switch mode power supply. Obviously it's got a diode in there instead of the second MOSFET. So you can do this with different hardware, and you can bulk up. For example, I've got these, which are, let me see if I can read it, FB25N15D, which I believe are something like about 36 amps. So obviously if you're using 36 amps, you'll have very high power supply, so this will need a very big heat spreader. And then basically all you're doing then is upping or paralleling hardware to make your high power power supply or buck converter. I call them power supplies because as long as you can adjust the power up or down, it doesn't really matter. So that would work. Obviously if you're using a higher ampage, your inductor needs to be bigger. How you do it is up to you. It's a combination of things, but literally it's your input, what gets pulled in. It's stored in the capacitor to smooth it as it's pulled to the inductor. So you'll get the capacitance needs to be able to supply the inductor, so they need to be in check together. And then lastly, your output power needs a smaller capacitor and probably a filter. I've literally just dragged up a box of bits, and I haven't got one in here. a ceramic capacitor just to smooth out the ripples that are caused. Now I found it was 0.0002 was my voltage ripple, and I'm quite happy with how it went. So I hope that's a little bit helpful. Just follow this diagram on screen and just pick up your parts, put it together and see what happens. These are available on AliExpress for about £2. eBay, they're probably about £6. When you wire them up, and I'm going to probably do a separate video on this, so click on to the next video. I'll do a completely different one specifically for this, because these are a pain in the arse. Thanks for watching. If you liked it, subscribe.